participants present in this. I am Prisha and I welcome you on the behalf of FCP Forum to this knowledge sharing series program. This is one initiative taken by FCP Forum to share the experiences and knowledge of the industry experts with our associates who are working in the fields of fluid conveyance programs. Before the start of the program, before the start of this, Before the start of the session, I would like to invite Mr. Anveer Polymets, sir, who is the founder of FCP Forum, to apprise about the vision and mission of FCP Forum. Over to you, sir.
Thank you, Prisha. Welcome all. This is Anup. Welcome to FCP Index, and I request everyone to mute your mobiles for voice calls, which will give a smooth and interactive session. First of all, we would like to say we don't endorse any particular brand or any particular manufacturer, but we represent the fluid conveyance world. So FCP, basically FCP Index and Connections Private Limited, it is in three verticals: FCP Prime, FCP Training, and FCP Forum. Under FCP Forum, we conduct this. It is basically about get trained, learn, network, sustain, grow, and innovate. In this program, in Get Trained, we and the learning program to take the benefit of the knowledge sharing. We conduct this to enhance the knowledge of forum members. FCP Forum conducts technical webinars on every second and fourth Saturday of month by industry professionals on various topics pertaining to FCP industry like hose assembly. So under this today the program, it is conducted by Shwetali madam. So back to you, Prisha, to get back to it. Thank you.
Yes, sir. Thank you so much. Now I would introduce the speaker of today's technical webinar, Mrs. Shweta Godase. Mr. Godase is a technocrat in rubber technology. She holds a postgraduate diploma IRI certification course from IIT Kharagpur. She is having more than 14 years of working experience in the field of rubber compound design and development. She is an entrepreneur and owner of Pune-based Anveer Polymets. This company manufactures a wide range of rubber products, especially critical products like O-rings, rubber molded components, extrusion profiles, and other sealing solutions which are used for different industrial applications. Now I request Mr. Godase to start today's session, which on the topic of various O-rings used in hydraulic hose ends and connections. Also, I would request all the participants to please keep their mic mute, and if they have any questions regarding the webinar, they can put that into the chat box, and ma'am will answer you at the end of the session. I welcome you, ma'am, on to this webinar, and I request all to have a great session. And over to you, ma'am. Thank you.
Thank you so much, ma'am. A very good afternoon, everyone. This is Shwetali Godase from Samarth Enterprises, Pune. So, first of all, thank you, Anup sir. And hope this presentation will be beneficial for all participants. So, let's start with the session. So, let's start our session with content. So today I am going to focus on following points. First is the fundamentals of O-rings. Second, application of O-rings. Sizing consideration, polymer selection with respect to properties, application, and its fluid compatibility. Then importance of physical properties of O-ring compounds. Failure mode analysis during application of O-ring. Process failure modes and analysis, molding and finishing defects and its solution during manufacturing of the parts, shelf life, storage of O-rings, and lastly, testing standards. So let's begin with the fundamentals. So first is, what is O-ring? The name itself explain about it is O-ring is a circular cross-sectional ring molded by rubber or plastics. Why we are using O-ring? O-rings are used to seal or block the path which may allow liquid or gas to escape. And how O-ring works? As the pressure of the sealing system begins to rise, the O-ring shifts to the opposite side of the pressure. And as the O-ring material is soft, the O-ring is mechanically squeezed and it blocks the gap between two mating hardware pieces. This is what actually happens with the O-ring during application. So now move towards applications of O-ring. O-rings are applied for static applications as well as dynamic applications. In static application, the axial seals, radial seals, and in dynamic application, hydraulic, pneumatic seals are there, rotary seals are there. So let's discuss more about the applications in detail. So first is a static axial seals. In static axial seals, there is no movement during sealing. That's why it's called a static. The sealing occurs parallel to the seal center line. That is, either the sealing is on top or bottom of the seal. So let's see designing part. While designing grooves for static axial seals, the first consideration in mind is pressure direction. That pressure, whether it is from inward or outward direction. When the pressure is in outward direction, the outside diameter of the groove is primary consideration. And for inward pressures, of course, the inside diameter is primary consideration. This designing is important to ensure that the O-ring should move the least distance to seal the extrusion gap. In liquid applications, where grooves are large, these are largest because to allow the increased swell. If the swelling issue is not anticipated, the smaller groove dimensions can be considered. Then static radial seals. In this type of applications, sealing surfaces are perpendicular to the seal. That is either on inner side or outer diameter of the side. There are two variations of the radial seal. You can see a picture of it here. One is a piston seal where groove is on piston. Illustration is in right side. And in second is a rod seal where groove is on the bore. You can see it in a left side. Then second is a dynamic application. So in dynamic sealing is basically associated with motions such as reciprocating, oscillating, and rotary motions. In dynamic reciprocating, O-ring type of application includes hydraulic and pneumatic piston seals or rod seals. In dynamic application, smaller diameter O-rings are generally works well for short stroke applications. And if long stroke applications are there, then definitely thicker cross-sectional O-rings are good to perform. There are a lot of damage modes because of the friction that occur during sealing in the dynamic type of sealing applications. And for static type of O-rings, such type of problems not observed because there is no friction at all. To increase the lifespan and efficiency of the seal, the surface finish of the hardware is extremely important factor. The perfect hardware surface microfinish is between 10 to 20 micro inches generally. If surface finish is too abrasive, it will rub the surface of an O-ring. And if the surface is too slicky or too slippery, we can say, it will disallow the o-ring to properly lubricated by the fluid film. So the surface finish should be maintained in proper, you can say proper finishing should be maintained for it. The second is a rotary seals. The o-rings have proven to be reliably rotary seals under proper conditions. One is a adequate durometer, second is a hardware configurations, third is a feet per minute values must be matched to proper o-ring compound. Here is the image of rotary seals where o-ring is applied around the rod, and a shaft hardness value of 55 Rockwell is typically required for successful rotary rings applications. So the next important part of the o-ring is its dimensions. When sizing consideration is there are three types of dimensions o-ring is having. One is the inner diameter, second is outer diameter, and cross section. So first we talk about ID, that is inner diameter. In standard practice, ID of o-ring must be smaller than the matting hardware. So that it allows o-ring to stretch within the groove. Typically 2% stretch is recommended, but theoretical possibilities are we can go up to 1 to 5% also. But we always keep in mind that when higher level of initial stretch will decrease the performance of the ring. So proper inner diameter should be selected with respect to the groove diameter. Here is the formula to calculate, approximate formula is given here to calculate the ID of the o-ring with respect to the groove diameters. So next important dimension is cross section of the o-ring. While design of a o-ring cross section is depend on the size of the gland. To create a proper amount of squeeze and to generate adequate sealing effect, the o-ring cross section must be larger than the gland height. And the diametric clearance. Diametric clearance is the gap between two matting hardware surfaces. In next slide, you can see here is the diametric clearance. You can see. So diametric clearance is nothing but the extrusion gap. We call it also call it as an extrusion gap. So the diametric clearance, that is the gap between two matting hardware surfaces, is important because the o-ring gets squeezed into that extrusion gap and sealing effect is arises there. So that gap is important. Then o-ring cross section is also depend on whether the application is in static or in dynamic. Because to reduce the friction in dynamic applications, smaller cross section is required. So by considering the application, we have to select proper cross section and its tolerances of the o-rings. So this is all about the dimensions of the o-ring. Here is a formula for approximate calculation of minimum value and maximum value of the cross section with respect to is groove diameter, bore diameter, and the diametric clearance, that is extrusion gap. And in the upper side of the slide, you can see how o-ring is installed in the installed during application. It is it's cross section of the application. First one is installed and second is under pressure. When pressure is applied, the o-ring shift is observed to the opposite side of the pressure. So let's talk briefly about the main important factors that is polymer selection. It's very important to select a proper polymer for proper application and proper results of our product. So first is a nitrile rubber. We also call it as a NBR. General type of O-rings are generally molded by nitrile rubber. Temperature range is -25 to +120 degrees Celsius. And with the special compounding chemicals, we can stretch that limit up to -40 degrees Celsius also. Then properties of the nitrile rubber. Nitrile rubber has a good mechanical properties, like it has good tensile strength, tear resistance, abrasion resistance, elongation properties, and compression set property, which makes nitrile rubber suitable for most of the sealing applications. The second is a nitrile has an excellent resistance to petroleum-based oil, fuel, greases, and some hydraulic liquids. Nitrile also has a moderate resistance to water, but it has good resistance to non-polar solvent. Non-polar solvents are chloroform, aromatic solvent, benzene, toluene, xylene, etc. Nitrile perform well in alcohols. It has good resistance to aliphatic hydrocarbons, that is methane, ethane, and propane. Then applications of nitrile seals. Nitrile seals are majorly used in agriculture, automotive industry, dairy, mining, plumbing, and railways. Of course, depend on the environmental conditions where the seal is going to use. Then limitations of nitrile rubber. We should avoid the use of nitrile seals in automotive brake fluids, in halogenated hydrocarbons, ketones, hydrocarbons. We also avoid nitrile in ozone resistance or weather resistant applications. Nitrile is not at all a good choice for high temperature and pressure demanding areas. So next is a hydrogenated nitrile rubber, that is HNBR. HNBR is a modified version of nitrile rubber. The basic structure is same, only presence of hydrogen makes it something special in the applications. The working temperature is -25 degrees Celsius to +150 degrees Celsius. Now properties of HNBR. The tensile strength, tear strength, elongation, abrasion resistance properties are excellent than nitrile rubber. HNBR has excellent mechanical properties as compared to the nitrile rubber. It has good resistance to ozone, sunlight, and other atmospheric environment, which nitrile rubber don't have. HNBR has better oil, fuel, and chemical resistance, and it also withstand much higher temperature than the nitrile rubber. It has excellent resistance to many chemicals like heat, hot water, steam. It also performs well in petroleum-based oils, fuels, aliphatic hydrocarbons, vegetable oils, greases, glycols, silicone oils. Usually, HNBR is cured by peroxide curing system, but we also can be cured with sulfur just to improve the flexing property in dynamic systems. But contrary, we have to compromise on compression set properties by sulfur curing. Peroxide curing gives better compression properties like heat resistance, also better in peroxide cure systems. So now let's talk about the limitations of HNBR rubber. HNBR has a poor electrical resistance properties, poor flame resistance, poor aromatic oil resistance. It is not applicable for polar organic solvent. And the compounds are susceptible to exposure to chlorinated hydrocarbons, esters, ethers, ketones, and strong acids. Now applications. We can use HNBR seals in automotive engine seals, fuel system seals, suspension seals, transmission system bonded piston seals. So it's all about HNBR. Next is a EPDM. EPDM is ethylene propylene diene monomer. Temperature range is -45 to +125 degrees Celsius. With the help of peroxide cure system, we can go up to +150 degrees Celsius also. The EPDM has a resistance to break fluid based on glycol up to 150 degrees Celsius. Of course, EPDM has hot water and steam resistance. It has good resistance to hydraulic fluid based on phosphate esters, resistance to organic acids as well as inorganic acids also. Organic acids are such as formic acid, citric acid, and inorganic acid are sulfuric acids, hydrochloric acids. It has resistance to silicon-based oil and greases. Polar solvents such as ketone, ester, alcohols resistance is also good in EPDM. Most commonly, EPDM rubber seals are used where ozone resistance or UV radiation properties or weather resistance properties are required. Sometimes EPDM rubber can be compounded for provide the excellent electrical resistance also. Now, limitations of the EPDM rubber. We cannot use EPDM rubber for the products based on mineral oils such as greases, oils, fuels. EPDM is not recommended for aliphatic or aromatic chlorinated hydrocarbons. Applications. We can use EPDM seals for food industries and for automotive industries. Next is a polyacrylic rubber, that is ACM. ACM polyacrylic has working temperature range -10 to 150 degrees Celsius. Polyacrylic rubber has an incredibly high resistance to hot hydraulic oils and oxidations. So this makes this rubber ideal for use in hydraulic machinery and equipment. The resistance to petroleum oils and high temperature is very good. Polyacrylic is naturally resistant to ozone and weathering. So it is superior in that area of application where nitrile is concerned. For weathering resistance, polyacrylic perform well as compared to the nitrile. It has a resistance to mineral oils also. Limitations include polyacrylic is having poor water resistance as well as low temperature resistance is very low. ACM is not suitable for the applications where below -10 degrees Celsius temperature is in the consideration. Below -10 we cannot use polyacrylic. It has poor level of acid resistance and alkali resistance. ACM does not have very low resilience in temperature below 70 degrees Celsius. Sorry, ACM has a very low resilience in temperature below 70 degrees Celsius. So application, we can use polyacrylic seals in automotive industry, including gearboxes, engines, and in power steerings and transmission systems. The next one is a silicone rubber. Silicone rubber is a VMQ, that is vinyl methyl silicone. Silicone is the rubber which is having a wide temperature range of application, that is from -60 to +270 degrees Celsius. Even it can be tolerated up to greater extremes like -100 degrees Celsius to 300 degrees Celsius, but of course for limited period of time, not for continuous use. Hence, Silicon is an ideal choice for application where high and low temperature both factors are required. Properties of the silicon rubber. The main property of silicon rubber is its insulation and flame retardant resistance. It has a great resistance to oil, solvent, grease, brake fluid. It can be used for hot air applications, engine, transmission oils. It offers excellent compression set properties, has a great low temperature flexibility, and it has weather and ozone attack resistance is outstanding. Now, limitations. What are the limitations? In spite of having excellent compression set, it has low physical properties, like it has low tensile strength, poor tear resistance property, which makes it not suitable for dynamic sealing applications. It has high gas permeability rate. It is not resistant to superheated steam, and we cannot use it in acids and alkaline medium. It is not recommended for hydrocarbon based fuels, that is gasoline, propane, diesel. Aromatic hydrocarbon resistance is also poor, and aromatic mineral oils also. It has fair resistance to abrasion and tearing, so it can use only for static applications rather than dynamic applications. Because dynamic applications require great abrasion resistance, tear strength should be best, or tensile property is required. These are requirements for dynamic sealing, which is not in case of silicon. Silicon is not meeting that properties at all. Second is applications. Silicon seals are generally used in FDA and medical devices. It is commonly used in pharmaceutical industries, and as it is a fire resistance material, so it is used in firefighting equipments also. Next one is a fluorosilicon, that is FVMQ. The working temperature is -57 to 205 degrees Celsius. The difference between silicon and fluorosilicon is having fluorine content in it, and that fluorine content makes fluorosilicon better than silicon. It has excellent temperature resistance property and is stable. It has stable properties in extreme temperature of environment. It has improved mechanical properties as compared to silicon. It has great resistance to fuel, oil, and chemicals. It has high flame and insulation resistance material. Application includes fluorosilicon seals are used in automotive, aerospace, fuel industries, electrical equipment seals, engine gaskets, jet fuel system, gas turbine seals. Now, limitations. It has poor abrasion resistance, poor tear resistance, and it is not recommended for ketones like acetones and organic acids exposure. Next one is a chlorinated rubber, that is neoprene. Temperature range is -35 to 100 degrees Celsius. Neoprene has an excellent balance of physical and chemical properties that makes it suitable for range of application. It has moderate resistance to petroleum-based oil and fuels, but a better chemical, oil, ozone, and heat resistance than the natural and nitrile rubber. It has a self-extinguishing rubber. The neoprene rubber is one of the few self-extinguishing rubber. So it used in flame resistance property, where flame resistance properties are required. Neoprene rubber is prime choice for it. It has a gas permeability relatively low. It has good level of rebound resilience. That neoprene contains chlorine atom in it. That's why the self-extinguishing property of the rubber is because of that chlorine atom, presence of that chlorine atom in it. Limitations of neoprene is exhibit poor electrical properties, so not recommended for electrical insulation. It has poor resistance to strong oxidizing acids like esters, ketones. Application includes as chemical inertness makes it valuable for industrial applications such as sealing gasket, electrical power transforms, marine usage, medical uses, etc. Next one is FMK, that is fluoroelastomer. Usually call it as a white-on. Working temperature is -20 to +200 degrees Celsius. White-on is highly fluorinated polymer. So it offers exceptional performance in extreme hot and corrosive environment because of the presence of fluorine in it. The advantages of white-on rubbers are it has exceptional temperature stability in extreme heights. It is chemically compatible to most of the chemicals like fuel oils, hydraulic oil, vegetable oils, octane, gasoline, alcohols, concentrated acids, mineral oils. Oil resistance is excellent in white on rubber. Aromatic petroleum solvent resistance is also excellent. White on seals can be used for flame resistance applications. Gas permeability is good. It has best ozone resistance. Oxidation, radiation resistance is fair, but oxidation resistance is excellent. Steam resistance is good. Sunlight resistance is good. Weather and water resistance is also excellent. Now, application of white-on O-rings. White-on O-rings are majorly used in aircraft O-rings or automotive component. FKM seals are used in corrosive environment as it is having fluorine content, which makes it special for special applications. So limitations of white-on. White-on has a limited use in low temperature environment because it does not remain flexible at low temperature for a long time. It is not recommended to exposure to ketones, amines. And second is a high cost. Now tetrafluoroethylene propylene, that is AFLAS. It has excellent temperature and chemical performance. Working temperature is -10 to 30 degrees Celsius. It has resistance to petroleum oil, steam, amines, chemical resistance to strong acid and bases. It has high electrical resistivity, ozone resistance to polar solvent. Resistance to polar solvent. It also has ozone resistance, and it also has resistance to radiation to some extent. Application is in aerospace, steam, hot water up to 204 degrees Celsius. On-field, oil-field applications. Limitations of AFLAS. It is not recommended for chlorinated hydrocarbons, that is trichloroethylene, ketones, and acetic acid environment. Next, the FFK, that is perfluoroelastomer. Perfluoroelastomer is the highest performing temperature and chemical property of any elastomer class. Temperature range is -55 to 330 degrees Celsius. It has low outgassing and extractable properties, high flame resistance. It has improved chemical resistance than FKM because it contains higher percentage of fluorine than FKM. FFKM has resistance to about 1800 plus different chemicals. Hence, it is majorly used for most of the challenging applications. So here I mentioned outgassing. Outgassing property means the release of gas when it is exposed to heat or vacuum, and that gas will be condensed on the other material and it can interfere in the performance of that seal. So low outgassing properties is important. Then applications. FFCAM seals are used in semiconductor, energy, pharmaceutical, and industrial industries. Used in environment with high temperature or harsh chemicals are involved. It's also used for aerospace application seals, vacuum applications. Limitations of FFCAM. FFCAM is not suitable for fluorinated solvent and perfluorinated lubricants. So it's all about the polymers which are going to used in molding of O-ring. Now, importance of physical properties on O-ring application. Physical properties like hardness, tensile strength, these are the physical properties. So why hardness is important in O-rings? So one of the key factor of getting a right O-ring for your application is getting a right hardness for your product. Hardness is measure of a resistance of the material, which we measured in the Shore A durometer. Higher the durometer, harder is the compound. In general, 70 Shore A durometer hardness should be used in standard practice because 70 hardness compounds offers a best combination of properties which are required for most of the O-rings applications. The softer the elastomer, the coefficient of friction is high. And soft elastomers also has better seal material conforms to surface to be sealed, and low pressure is required to create a seal in softer hardness. So this property is important in low pressure seals which are not activated by fluid pressures. And in dynamic applications, hard compound generally used because the hard compound with low coefficient of friction shows high friction values because the load required to squeeze that hard material into O-ring groove is much greater. The soft elastomer also has more risk at high operating pressures because the elastomer of O-ring will extrude into the clearance gap between the matting seal surfaces. So use of harder material is recommended. Standard for measuring hardness is ASTM D2240, BS2719, DIN 53505, ISO 7619. Next important property is compression set. Compression set is the percent of deflection that the elastomer fails to recover after a fixed period of time under specific squeeze or stressed and temperature. The formula for calculating compression set is given. Here three images are, you can see on the screen, three images are there. First one is rubber in the free state. Second is a rubber in the compressed state. And third is after compression and after giving some recovery period to that specimen, that height is measured in H2. The third picture shows that height, that is after recovery. Standard used for compression set is ASTM D395. Next is a tensile strength, percent elongation and percent volume swelling. These three properties plays an important role in performance of the O-ring because these properties indicates the deterioration of the compound or seal after it has been in contact with the testing fluid or system fluid for a long period of time. Larger the reduction in the properties indicates poor performance of the seal. The standard used for testing is ASTM D412, DIN 53505, BS 903. Now let's talk on the failure modes, the general factors affecting O-ring failure during application. O-ring application failure is depend on various environmental factors like improper gland design. Gland designing is very important because it allows too much or too little compression room to seal. Second is the incorrect O-ring size. Third is the incompatibility of the O-ring elastomer and the environmental element. Third is the improper O-ring installation, inadequate O-ring lubrication. These are the factors which adversely affect the performance of the O-ring. Then failure modes caused by improper designing of compound and gland. The failure modes, we used O-ring as a seal where combination of stresses applied on O-ring and which are very complex and difficult to evaluate. Therefore, it is very important that the O-ring compound and size should be tested in real environment of its service. The following types of failures can occur during testing or during application. The first failure is compression set failure. The most common cause of O-ring failure is compression set. An effective O-ring seal should require continuous seal line between the seal surface. No excessive deformation should occur on O-ring, so that maintain the sealing factor. If excessive deformation is occurred, then sealing factor is not in proper way. So compression set values are very important in that aspects. Lower the percent of compression set value, higher the performance of the O-ring. So these are the factors. So which factors contribute to compression set failure? First, if we select O-ring material which inherently has poor compression set, improper gland design, if excessive temperature is developed during O-ring, then O-ring get hardened and lose its elasticity property. And temperature can be developed during application just because of the system fluid, maybe because of external environmental factors, or the frictional heat buildup is also a responsible factor for the heat high temperature. Then volume swell of the O-ring due to system fluid. If O-ring absorb excess of fluid from the system, that O-ring get swell, and because of that swelling, compression set is get hampered. The next reason is excessive squeeze of O-ring due to over tightening of the adjustable glands. The incomplete curing of O-ring material during production is also leads to compression set failure. Then introduction of fluid incompatible with O-ring material. Then preventions. So we can prevent this by choosing low set O-rings materials, by selecting O-ring material which is compatible to service conditions. We can reduce system operating pressures. We can check the frictional heat buildup at the seal interface and reduce if excessive heat is generated. We can inspect the incoming O-ring shipment for the correct physical properties. Then how we can identify the failure because of the compression set. So in this image here you can see The top and bottom surface of the ring is flat. That is, O-shaped is permanently deformed into flat surface. When such type of O-ring is observed on field, so this is because of the compression set failure. Next is the extrusion and nibbling. Extrusion and nibbling of the O-ring is primary cause of seal failure in dynamic applications mainly, and in static applications this is subject to high pressure. If very high pressure is applied in static application, then such type of problem may get countered. Then failure analysis of extrusion and nibbling failure. First is excessive clearance. If excess high pressure is applied, that is pressure which is designed by the system, great extra pressure than that is applied, then such type of failure may observe. If O-ring material is too soft, it cannot withstand the temperature. Then next one is if degradation occurs. Degradation is in the form of swelling, softening, shrinking, or cracking. Next is irregular clearance gap caused by eccentricity. Then also this type of failure is observed. Increased in the clearance gap due to excessive system pressure leads to the failure. Improper machining of O-ring glands, that is, if sharp edges are there, then also this problem is occur. Improper size, that is, too large O-ring is installed, causing excess filling of the groove. So preventions for this: one is we can decrease the clearance by reducing machining tolerance. One can use backup devices. We can check O-ring material for compatible with the system fluids. We increase the rigidity of the metal component. We replace the current O-ring with harder O-ring, or we break the sharp edges of the gland. We can ensure the installation of proper size of O-rings. We also can use alternative seal shape. For example, in some long stroke piston or rod seal applications, the T seal or the backup rings may be used to prevent the extrusion and spiral failures. Then identification, here is the image which shows the extrusion and nibbling failure. Now abrasion. The abrasion failure is only observed in the dynamic seal, subject to its movements, like whether it reciprocating, oscillating, or rotary motion. The failure analysis is, it is because of improper finish of the surface in the dynamic contact with the O-ring. This surface may be too rough, acting as an abrasive, or it may be too smooth, causing inadequate lubrication due to inability of surface to hold the lubricant. Next is if improper lubrication is provided by the system, if excess temperature is generated by any reason, it can lead to abrasion of the seal. The next is a contamination of the system fluid by abrasive particles. Then how we can prevent this problem? So we can minimize this by use of proper surface finished material. We can provide adequate lubrication by use of proper system fluids. Then we can internally lubricate the O-rings to reduce the friction and wear. We can also check for the contamination of the fluids, and to eliminate the sources, installation of filters if necessary, we can do that. Consider the changing of O-ring material with improved abrasion resistance material. Here is the image showing abrasive section of the O-ring, how it looks in failure when abrasion resistance failure is observed. Then next is the installation damages. See, in spite of its simple appearance, O-ring required care during installation, because installation can directly attribute it to its O-ring performance failure. So the failure analysis. So if there is a sharp corners on the metals components such as O-ring glands or threads over which O-ring is passing during assembly, it leads to damages. Insufficient lead in chamfer. If there is a blind groove in multi-port valves, then also O-ring can get damaged. If oversized O-ring is applied for piston seals, if undersize O-ring can applied on rod seals, if O-ring get twisted during installation, then also it can damage the O-ring. O-ring is not properly lubricated before installation. This is also one of the cause. If the O-ring glands or surface on which O-ring must pass or is resting on the resting surface of the O-ring is contaminated with the metal part, then also it can damage the seal. Then prevention. How we can prevent? We can prevent this by, it's important to break all sharp edges on the metal components by providing lead in the chamfer. We have to check for all components for the cleanliness before installation. We have to tap all threads over which O-ring will pass. Use of O-ring lubricants, and also if we use lubricants, that lubricants must not contaminate the system fluid also. That is also important factor to be keep in mind. Then double check of the O-ring to ensure the correct size and material. So these precautions we have to take while installation of O-rings. Then explosive decompression. As the system pressure decreases, this type of failure may occur. So explosive decompression is also termed as a O-ring embolism. In this, after a period of service under high pressure, when we reduce the pressure too rapidly, the gas trapped within the internal structure of the O-ring is expands, and which leads to a small ruptures or embolisms in the O-ring surfaces, and that rupture causes the failure in the application of the seal. So prevention is, we can increase the decompression time to allow the trapped gas to work out of the seal material. Then we can choose seal material with good resistance to explosive decompression. Then third one, if the problem persists, the pressure are very high, then we have to use the metal seals rather than rubber or polymer seals. Then identification is, there is a small pits or blisters on the surface of the O-ring which indicate the failure by explosive decompression. So now molding defects, that is during production, which defects are occur and how we encounter that. First is a mold fouling. If the residue is allowed to remain on the mold for a long period of time, it gradually is built in the thickness and it eventually causes the molding defects to the finishing part. Prevention is, after each number of stroke we have to clean the mold. Proper release agent should be used on the mold. Second is a blistering. Blistering caused by uncured rubber compound. Prevention is, we have to give proper cure time and temperature. We have to, if necessary, we have to cross verify the recipe for the compounding. Then contamination. Contamination of contaminated finished part is a result of the foreign material in the raw rubber compound. And the prevention is, we have to keep working area clean and neat in every stage of production, and proper handling is required. Then flow lines. The material flow creates a multiple visible lines or patterns on the finished product. So this is called as a flow lines. Prevention is rubber compound. If rubber compound is having low flow property or less flowing property, then such type of lines may occur. If pressure is low, that is molding pressure is low, then this type of problem may get counter. So we have to increase the molding pressure if required. We have to check the mold surface damages. These are the preventions. Then short molding. Short molding is like if part is a rubber short or incomplete molded part is observed, we can call it as a short molding. Prevention is we needs to increase the molding pressure or die closing speed. We have to check for the die closing speed, or if necessary we have to rectify the rubber compound. Air traps. Formation of air pockets on the surface part caused air trap problem, or air trap problem is identified as if on the o-ring air pockets are seen, small air pockets are there, so this is the air trap. So prevention is holding correct pressure and mold is not correctly centered. This type of problem may get observed. The next one is a shelf life. Shelf life of the rubber o-ring or rubber molded product is given here. For thermoplastic, it is 4 years. For nitrile, HNBR, CR is 6 years. EPDM is having 8 years of shelf life because EPDM has good weather resistance property. We can store it for more time, longer time. FKM, silicon, fluorosilicon is having 10 years of shelf life. FFKM has 18 years of shelf life. PTFE, we can store it for unlimited period of time. So for fluorosilicon or FFKM, presence of fluorine atom, because of that, it has more environmental resistance. So the shelf life increases accordingly. And these guidelines are taken from the ISO 2230 DIN 7716 standard. Then storage recommendations. We have to keep storage area cool, dry, and moderately ventilated, and there is as less dust as possible. We have to avoid outdoor storage. The most favorable storage temperature is 15 to 25 degrees Celsius. We should wrap the seals and store them in airtight containers, protecting away from the atmospheric changes. The elastomer product should not be subject to tension, compression, or any form of load during storage, as it can form permanent deformation or cracks on the product. The seal made of different material should not be in contact with each other. And this is very important when different color products are there. We have to keep different color products in different containers to avoid the discoloration problem. The seals should be stored for shortest period as possible. We have to use the method of first in, first out. And these guidelines of storage of the seal are in accordance with ISO 2230 DIN 7716 standard. Here is the list of standards with detailing. SAE, military standard, BS, ISO, DIN standards are used for testing and inspection guidelines of the O-rings. So it's all about O-ring. Thank you so much for patience hearing. I hope the presentation covers all the required detailing regarding O-ring and is helpful for you.
Yes, certainly.
Thank you.
It was a very good session. An eye opener. Even working in this industry for about 30 years, I learned many things from this session, madam. Thank you.
Thank you so much, sir, for inviting me and for the opportunity to share my knowledge with all of you.
Nitirji.
Yes. So in case anyone is having any query, any question, they can ask directly to the madam. There is one question like, why should we not use NBR O-rings in braking system? So this question is from high-tech engineering. Why should we not use NBR O-rings in braking system?
Yeah, we
Braking
can.
systems.
Yeah, we can mail the things to the concerned query based.
Okay. Okay, sir.
I will mail the detail, all the details to Anup sir, and they can convey it to the.
Thank you.
Any question? Deepak Khot sir. Rohit sir, Rohit Chechani ji.
Hello.
Hello.
Yes.
Yeah, good afternoon, sir. Good afternoon to all. The session was
Yes.
very good and very much informative, sir.
Okay.
खोत साहेब आवाज ऐकून बरं वाटला.
Thank you, sir. Thank you. भेटू आपण in person.
Yes.
Yes, sir.
भेटो. Yes.
Okay, sir. Okay.
सर इथे ब्रेकिंग सिस्टीम मध्ये म्हणजे त्यांना जर ब्रेक फ्लुइड ऍप्लिकेशन साठी जर विचारायचं असेल तर ब्रेक फ्लुइड मध्ये
they are making some adapters. They are supplying some adapters to the braking system. So he is asking whether why NBR cannot be used in braking system. That is the things we'll discuss one to one and we can answer it to madam.
Okay, so no issues, no issues.
रोहित जी, चेतनी साहब.
हाँ, कैसे हैं?
बढ़िया सर. आप कैसे सर?
बस fine, everything is fine.
Any questions regarding this O-rings?
O-rings में एक था, I mean there are some special O-rings like encapsulated. वो क्या हो? I mean is there any special cover being done on that O-ring particular? Like if someone asks encapsulated, NBR encapsulated, या फिर whiten encapsulated. So what that does mean and how does it improve the overall performance of the O-ring?
Sir, sorry, actually I am also not much aware about encapsulated O-rings, but as per my knowledge, some like PTFE material or that coating is made on that O-ring.
Okay, yeah, that's some sort of coating only.
Coating which makes it useful or to just increase the resistance of that seal for particular application. The encapsulated O-rings can used.
Okay, so that's I mean that process can be applied after the O-rings are made, or it should be, I mean it is a ongoing process, like during the manufacturing process itself, or if I ask some person, I mean I need some Teflon coating on my O-rings which I have, can it be done at a later stage also? If I am holding some O-rings like in NBR and I want it to be Teflon coated at a later stage, I mean,
sir,
can
we
it be
can
done,
do
or
it, but it is very critical process of coating.
Okay.
Because of course the dimensional challenges are there.
Okay.
If you want to coat your O-ring with some other material,
yes.
So how we can coat it?
Okay,
So
I mean it's a process. I mean at the very first stage itself, when the O-rings are
yes.
being manufactured.
Yes.
Okay, thank you.
Okay.
Thank you, Niteshji. Thank you, Anupji.
Thank you.
Thank you, sir. Thank you.
Thank you.
So I think there is no more questions now. So thank you very much, Shwetali madam. It was very informative and knowledgeable session, and you have covered various things related to O-rings, which we were not aware. It is very small thing, but it is very critical for the different application. So, what are the different type of O-rings? What is the material used? What is the properties of this material? What is the different applications? What is the failure analysis? So all these factors you have covered in a very nice and informative way. So thank you very much, and you have spared your valuable time in giving this presentation, and I think you have worked almost many days to prepare this presentation. So I would like to thank you on behalf of FCP Index. So this recording of this presentation will be available on YouTube channel also. So by tomorrow or day after tomorrow, we will be sharing the link of this recording to all the people who could not able to join because of some regions. So thank you again, Shwetali madam, and I would like to thank the participants also. So thank you very much.
Thank you, sir. Thank you.
Thank you. Thank you. Thank you, madam.
Thank you, Anupji.
Thank you. Thank you. Thank you, sir.
Okay, sir. Okay.
Okay.